Welcome to lecture 39. In this experiment, I will be showing how we can interface accelerometer with STM board and what value we will get for the different axes like x, y and z axis in the CoolTerm. We already know how we have to use CoolTerm along with STM board. For Arduino it is straightforward, it can be printed in the serial monitor, but in this case for STM board we have to install some hyperterminal. So, here I will be using CoolTerm for the same. So, firstly I will show you the experiment with accelerometer and then I will do the demonstration. So, this is the ADXL335 accelerometer and I will be doing the connection with STM kit. So, the voltage source VCC will be connected to plus 5 volt, the ground will be connected to the ground pin of the STM board and the X, Y and Z out analog pin output will be connected to the analog input pins A0, A1 and A2. So, this is how the connection goes. This is the connection diagram. We can see this is the accelerometer, VCC is connected to 5 volt, ground is connected to the ground of STM and X, Y and Z out are connected with A0, A1 and A2. Okay. So, this is a straightforward connection that we will make. And then let us understand this analysis for the movement along x axis. When you hold the accelerometer, you will find out that accelerometer is having certain axes. One is along x, another is y and this one is z. When you hold the accelerometer towards this x, along this x, then you will see the highest value that you receive for this x. Similarly, if you hold it like this, the value of x should be minimum. Similarly, for y, if you hold it this way, the y value will be maximum, and if you hold it in this way, the y value will be minimum. Depending on this, you will be able to actually understand how you are holding the device, whether the device is straight or it is tilted or it is vertically tilted to the left or it is vertically tilted to the right. So, different orientation of a device could be figured out from this value. Similarly, if you hold the accelerometer in this direction, then the z value will be minimum here and the z value will be maximum here. Okay. So, we will try out this with the STM kit. Prior to that, I will discuss the code. Once I discuss the entire code, then I will be going and showing you the demonstration. So, let us understand the embed C code. So, this says that we have to include the embed library embed.each. First thing, we have to make the serial communication with USB TX and USB RX with the communication name as PC. We defined 3 analog input signals here. One is analog in X, the name we are giving it as X, which will be connected to port pin number A0 of the STM board. Similarly, if you see this next one, this is the analog input pin Y, which will be connected to A1 pin of STM, and the analog pin analog input Z, the name Z will be associated with A2. So, X out, Y out and Z out will be connected to the Arduino analog, the Arduino compatible, of course, the STM pins which is A0, A1 and A2. Then goes the main function. In the main function we define 3 variables, that is x1, y1 and z1, where we are reading the analog value using the function x dot read underscore u16, y1 will be y dot read underscore u16 and z1 will be z dot read underscore u16. And what we are doing, the serial communication with the name PC that we have already made will be used to print the values of this x, y and z coordinate, which is stored in variable x1, y1 and z1. So, this is how it goes, and this is going in a while loop, but after 1 second it will get printed. Okay. It will, after it gets printed, it will wait for 1 second and again it will do the same process. So, if you see the code is fairly simple, where we are just connecting the analog pins A0, A1 and A2 with X, Y and Z output of the accelerometer, and then we are simply printing it to the hyper terminal. Here we will be using CoolTerm, as I said. What you can do basically, if you wanted to see how the XYZ coordinate value changes, you can also use some kind of MATLAB code to display it, which we are not showing it here, but if you are interested, we can share those codes with you. You can try out at your end by plotting this x, y and z coordinates. Okay. Or you can do another thing, you can read this value, store it in some online database, as we have shown you earlier using the SMS control. You can use the GPRS facility to upload that, and whatever value is stored in that database, you can actually analyze it based on that. You can plot that as well. So, there are a variety of ways you can do it. So, finally, the plot looks somewhat like this. This is the sample output waveform from the accelerometer. So, this is the x axis, y axis and z axis value. This is how it is changing. Okay. So, there are certain spikes as well, we can see here and here there are certain spikes. So, this is how this particular plot looks like when we use the accelerometer and we accelerate, we move it up and down or in any position. So, now I will be showing you the demonstration of this using CoolTerm. So, first of all, you have to do the needful. You have to use this CoolTerm, okay, where I am clearing the data. So, some data it is coming. So, first we will see the connection here. Okay. Okay. Now, see how we have connected here. This is basically, this one is the BCC, this is the VCC which is connected to 5 volt. This is x axis which is connected to, you can see, A0. This is y axis, this one which is connected to A1, and this one is Z which is connected to A2, and finally, this one is connected to the ground pin. Okay. So, the connection is fairly straightforward. This is all is required here for the connection. Now, if you see this accelerometer properly, okay, if you see this accelerometer properly, you can see there is a x axis here. Okay. You see this, there is a x axis here. Okay. The same way I have shown you the diagram, this one is the x axis. Here is the y axis. okay, and this is the Z1. Okay. So, now you will see that whenever you hold this accelerometer with the arrow towards this x axis in this fashion, then the x coordinate value will be the highest. So, let us say I have hold the accelerometer in this fashion and will come and see the value of x in the hyperterminal. So, now see. So, these we are printing the x, y and z axis values. You can see the x axis value is 44058. Okay. The y axis is 36873 and of course, it varies. Okay. It is not the same, although I have hold it very tightly, but still there are some variation. There is a noise, etc., etc. So, there is a variation. So, this is the x axis value. Now, I will make sure that the y axis value will be maximum. So, I have put up the accelerometer with y axis at the top. So, now you can see in the hyperterminal what value you are getting. So, just see what value we are getting. We are getting the x axis value as 36728, the y axis value as 44426 and the z axis as 18628. Okay. So, what is the idea of showing you these values? So, the idea of showing you this value is that suppose you have this particular device put in some other device. Let us say you have a small piece of some box in place where you wanted to see that the orientation of that particular thing should always be like the head of that particular thing should be at the top. So, you can always make sure that the x axis value should be high, such that you have put up this accelerometer in that application in such a way that x axis is like this. So, if it is like this, the x axis value you will receive the highest one, and if it is not the highest, then the other two values are highest, then you have to make sure that your device is not properly placed. Okay. So, some kind of alert may be given that the device is not properly placed. Okay. So, these are the values which are coming. From this experiment, what we have understood is that how we can interface the accelerometer using STM kit, and like if we want to find out the orientation of a device, how we can find it out using this, and if we want a particular device to be placed in a particular way, we can ensure that using this. So, if somebody changes it, an alert can be sent out. Okay. And in every mobile device, this accelerometer, we have this accelerometer in place. If you must have used some kind of apps like health monitoring app, right? What it shows you that how many steps you have walked in a day, let us say. Okay. So, these are measured using this device. So, inside our mobile phone we have an accelerometer or a gyroscope. So, that gives us the acceleration movement that we make in a day. Of course, there are some issues with these devices as well, because if you are just having a jerk, then also it will take into consideration that you are walking. Okay. So, those things we need to look upon when we build an application, but generally this is the application of accelerometer, which is in various health monitoring apps, the smart watches that we use. So, all these in all these devices this accelerometer is there. Thank you.